I'm going to talk about how Docker, in combination with SBT, can make your life a bit easier when you're trying to do integration testing for your application, in particular for microservices. Okay, a bit about myself. I'm a software consultant based in London, so I'm building software for about 15 years, and lately I've been doing mostly backend stuff. I used to be in the old days more like a full stack developer. So nowadays doing more backend coding, and in particular most of my applications that tend to follow the microservices kind of architecture. And you can, I'm working right now at hotels.com. I'm in a team called SEM Tools. SEM stands for Search Engine Marketing. Basically, we have a few teams of search engine marketing specialists, which are taking care of the all the advertisement for the hotels in the system, in the hotels.com website. And there's quite a huge amount of campaigns and keywords combinations that they are managing. And what we do, me and my team, we're taking care of building some sort of automation tools for them to be able to apply, let's say, some rules over multiple accounts, or we have a set of automated tasks which are going to Google AdWords, using their APIs, to Microsoft Bing, grabbing the data from their system and apply some business rules, and then we generate some reports for our specialists. You can find me on Twitter, and on my GitHub account, you will find, you can, I'm going to give you the exact link later. You can find a project with the slides from today, and with like a ready project that you can run and yeah, get inspired maybe. And of course, if you want to send me a LinkedIn request, you can find me on LinkedIn. So a bit about multi-services architecture. Why do we do it this way? So I guess there are a lot of companies which start small, or maybe for newer projects, you just start small and you just build like a monolith, right? And then your application grows. And then, let's say in the beginning, maybe it eats up 2 gigs of RAM, right? When it's like in the early days. And then you add more features, and then you add more users, and then you add more data sources. And then it grows, it grows, it grows. And then at some point, you end up having a huge monolith that cannot fit in like a regular server, and then you need to do some hacks around if you want to continue that way. Now, as opposed to that, the multi-services architecture is allowing you to scale better in different areas of your system, and of course, you overcome all these problems that I told you about. So the advantages, you can separate into reusable components. So different applications can benefit of the existence of a specific service, right? So instead of incorporating the same functionality in every application that you build, maybe you have like a central service that you can use from different applications. You can you can scale when you have bottlenecks in a particular area or of the system. So this allows you, let's say, if you have 3 services and one of them really needs like more processing power or maybe more memory, then you can go there and then deploy that particular service on maybe more beefy machines, or maybe run more nodes for that particular one, instead of, for example, with a monolith, you would have to deploy all the application on so many nodes that would have to accommodate everything. One very important. I was talking with a client a few days ago, and they were. I asked them, like, okay, so how many people are on your team? And they said, well, we have about 10 developers. And I asked them, so how do you manage like your daily stand-up? Isn't it taking like half an hour or something? Like when everybody has to tell what they've done? And they were saying, oh, yeah, we kind of manage that. In my experience with the agile methodologies, I noticed that a good team size is like 5-6 people. And it's very important to split at some point, maybe those 10 developers in 2 different teams. And then what you can do, you can split the work between them. Basically, each of the teams can take ownership of some part in the system and then build their own services and interact with the other teams at basically the kind of protocol level, at the contract level, right? And another reason to use microservices is that you can basically choose what technology to use for a particular part of the system. I was watching a video a few years ago. There was a guy explaining about some concept called anarchy development. So there was a company. They had this this team of developers, and their philosophy was like, you know what? The developers can do whatever they do. It's like that. Allow them to be anarchic. Just if you want to do something, just do it. And one of the examples was that they had a service, right? So one of the programmers wrote that service in Java, I think. And he said, like, yeah, it was using 50 servers to run this job or whatever to manage the load. And then, like, next week, so what happened? Well, I just rewrote it in Clojure, and then now it's using just 20 servers. So that's, I think, a good example that sometimes you might want to change the architecture, change the technology, change the programming language. I don't know, maybe you want to write it in Scala, or maybe next day you feel that Haskell is better, or I don't know. So that will allow you to change or to refactor your system in a granular way. Now, of course, the microservices architecture comes with some challenges, because when you have a monolith, it's kind of simple, especially with a strongly typed language. You have everything compiled, so everything is cross-checked. The compiler is going to inform you, hey, you're not respecting here the types anymore, right? Now, when you split into different services, then you have to be careful, because you have to define like a contract between the services, and you have to make sure that that contract remains, it remains the same. You're not breaking the contract when you're doing changes. And that usually happens when, especially when different teams work on different services, sometimes the contract might be broken. And you have to at least be aware of that and inform all the parts in the system. Now, that can be usually avoided by creating like a comprehensive suite of integration tests. And basically, that means that you have, let's say, like some services, S1 to Sn, and then you can set up some sort of test environment where you put all the services that you want to test together and you configure them. You might want to get some test data injected, to populate a bit with test data. And then you might want to run a bunch of tests. You test, for example, when you're hitting system A, you know that it interacts in the backend with in the background with system B, and you might want to do some sort of inspection that the actual behavior has happened. And yeah, you run these tests against the test environment and continue like this until you are actually satisfied with the results. You think that you covered all the test cases, and yeah. Now, the value that I find in integration testing is that I know that, okay, I might not cover today all the corner cases, but if I have like a suite of good tests, I know that I can go to one part of the system and I can confidently start refactoring or adding new features. And then when I run my tests, I will see if I accidentally broke the contract or if the system is still acting properly. Just as a quick example, so suppose that we have a website with a UI, with a simple UI, and that is backed by the account service. So the user will come on the website and will attempt to create an account. Now, of course, there's like a checkbox over there, and then we ask the user if they would like to subscribe to the newsletter as well. And the scenario that I was thinking of is that the website is going to create a request to the account service, and the account service, after creating the actual account, is going to send another request to the newsletter service to subscribe the user to this newsletter. Now, an integration test would look more like this. As I told you, it's like create the user first, and then expect that the account service is going to subscribe the user to the newsletter service, and then I should receive the user as the response to the REST call, and then at this moment I would just verify that the user was created as I expected, and then later on in the same test I would just do a call to the newsletter service to check that this user is already subscribed as I expected to the newsletter, and yeah, verify the response. So just an example of a test setup, what would we need? We need to deploy the newsletter service as a dependency, and then suppose that the account service is using MariaDB for storing the actual users, the actual accounts. We need to deploy that one. Then we need to deploy the account service and eventually inject some test data with some test accounts that we might need to check later on. And then configure these services so that they know about each other. Like, right, for the account service, we need to know, let's say, what's the IP or where's the address of the newsletter service, right? So in different environments, let's say on your laptop, you might have a different configuration for that. And in other environments like staging or production, you will change that that link, that configuration. Now, of course, all these dependencies that I told you, it's quite a lot. I mean, you can do it by hand if you want, but it's a bit, I think it's too much. And then Docker is your friend. With Docker, you can basically encapsulate all these services, all these dependencies in individual containers, and especially for, let's say, MariaDB or for other, I don't know, systems that you might need. There's a huge database of Docker images, so you can just grab one without installing that software on your computer or on a server. Just grab a Docker image, use it, and easily start it up as a dependency for your tests. And then just once you're done, you can just get rid of that. Another thing is that Docker, by encapsulating your applications in Docker, with Docker, you can guarantee that your software is always going to run the same. So it's not like you go and install it on some other machine, and then in production suddenly you have a difference in, I don't know, the packages that are installed on a system or the version of, I don't know what system utility. And with Docker, your application is going to run locally the same as in production. Like you have the same setup for your system. And yeah, it's easy to scale and deploy. So there are various solutions, Kubernetes, Mesos. So once you do it like this, once you use Docker, then you can basically use one of these solutions in production to deploy your Docker containers. So there's one plugin for SBT. It's called SBT Native plugin, which basically has different features. Like you can pack your application if you want in like a Debian package or in an RPM plugin, in an RPM package if you need, and eventually in a Docker container, in a Docker image. So the configuration is pretty straightforward. It's very simple. So what I was declaring is two Docker settings. One is the base image, the Linux image that I want to use. I'm using Alpine because it's quite a small this Linux distribution. It's quite light. And then the second option is about updating. When I'm creating the actual image, it will update. It will make some sort of link to the latest. Will point to the last one that I generated, the Docker image. And I'm using these Docker settings, and an extra configuration is the port, which is very important. which is the port that I'm exposing from the Docker container, and that's the port where the application is going to listen. And of course, you have to specify the plugins for these SBT Native plugin that you want to use. So the Docker plugin, which depends on the Java app packaging, is basically going to wrap your application with some start script. And the script plugin is actually giving you more support for the Alpine Linux image in particular. So this is the command that you can have to run to generate the images. SBT Docker publish local. That's going to publish these images. It's going to build the images and publish them on my local repository. And this is basically the generated Docker file. You should not bother too much, but I just wanted to show it to you. And then for running the actual Docker images, I'm using Docker Compose. So this is the file that I put together. And here I have the 3 dependencies, the newsletter service, and then the account DB, and then the account service. Each of them with their ports configuration. And then, very important, so I have a links section, basically for the account service that will have to know, that will have to be able to connect to the account DB and to the newsletter service. And also some environment variables which allow me to pass some configuration to the account service, where if you can see that I'm specifying the DB host is account DB, which is actually the name of the link, and the newsletter host is newsletter service, and that makes it possible for my account service container to connect to these 2 dependency containers. Spinning up the services, very simple, Docker Compose, run with the file that I just showed you. And then running the tests, I have basically like a multi-project SBT file. And one of them is the newsletter service test, which contains the tests, the integration test. Notice that I specify the configuration. So I'm using a ci.conf. Basically, that comes from continuous integration. I just chose it like this. Is where I'm passing a different configuration for the tests. And that looks like this. It needs to know to which IP to connect to run the tests. Basically, it has to connect to the account service and to the newsletter service. And then the extra config variable is Docker IP, where is basically the IP of the Docker host. And my tests are going to use this IP and the specified ports to connect to the 2 services. So I can quickly show you basically this should run pretty fast. So I'm doing the Docker publish local, and that's going to put together the images and publish them in my local Docker image repository. That's it. Now I can run Docker images. And so it shows that 7 seconds ago, it created the account service, 1.0 snapshot, and notice the latest. So it's basically the same image. And then newsletter service as well. So now that we have the images, we can do Docker compose up -d. So it created the containers. If I do Docker ps, I can see that the containers started. And right now I can run my tests. I'll just copy the command to be faster. So it shows here, it logged that it did some stuff, like it connected to the actual services, and yeah. I'm not going to get into details. You can basically find all the code and all the tests on my GitHub account. I'm going to show the link to the slides and the code. So you can do it on your own time. So this is the link, and any questions?
You mentioned as one of the challenges of microservices, keeping contracts in sync across teams and microservices. Do you have any advice, any best practices on how to keep these things in sync rather than waiting for it to fail?
Well, in the past, I've been working in a team. We were Scala developers, and there was another team of developers that they had like a service written in C#. And the way we did it was defining before we would, let's say, change a feature or change the system, we would analyze if that breaks the API. So we would first document at the API level and kind of specify the contract or the contract changes. And then we would start working on the actual implementation. Now, of course, we had a comprehensive set of tests that was capturing all the API endpoints, and we're making sure that whenever you change the API, sometimes you just do it accidentally, right? That show is going to show that you broke the contract. So one is documenting first and trying to understand where you're going to change the actual contract, and second of all, keeping like a good set of tests as low as possible. Like if you can do it just at your API level and you don't do it more like on the integration level, that's better. And then add up at the higher level with the integration.
Hi, we kind of follow the approach you described here, but we also run the test inside the continuous integration, like Jenkins. That runs also inside the Docker container. And we face some issues running concurrent jobs at the same time because all that will try to start Docker concurrently, and that cause issues. Did you run into the same kind of problems, and how did you solve it?
What kind of concurrent issues?
Like one job is running the integration test, and the other one shuts down Docker, the containers.
So you're using the same containers
Yeah, because
from two different jobs?
yes.
Well, the way I see it, if you have a job that is doing the continuous integration, ideally you should keep it isolated, because when you have other jobs or other I don't know, programs accessing that part, you're not going to be sure that your tests are accurate. I mean, you might have some parasite data coming up, or I don't know. It's best, if you can, to do it in isolation, or otherwise think about writing your tests in such a way that they don't fail if someone is adding a new user, let's say, from another system. Does it make sense? If you want, we can talk about this.
Any other questions? No, thank you.
Thank you.